Hello everyone, welcome back to our channel. So in this lecture 4 we will discuss regarding the types of traversals in a tree. First we will discuss pre-order, then in-order and post-order, and simultaneously we'll write the code of all three. And in the next video we will discuss the very important traversal, that is level order traversal. So without wasting any time, let us start. So what do we mean by, first of all, traversal? Traversal is, for example, this is our tree. Okay, this is a binary tree, and traversals means I'm starting from this root node. I'm standing here at root node and I want to visit all the nodes. So how can I visit? For example, I can do in one way. I can first come down in the left, and from this node I have two choices, here and here. Let us say I came here left, and from this node I again have two choices. So there are so many number of ways of traversing a tree. For that we have some types of traversals which we use in our problems. So these three are basic and most important, that is pre-order, then in-order, then post-order. Okay, so in these three type of traversals, kindly focus on this prefix, that is pre, in and post. Like whenever a question of traversal comes, so these prefix are kind of a hint for us to even write the code. So now let us continue with our first type, that is pre-order traversal. Pre-order. So first I'll do a dry run. I'll explain how this traversal works, then I'll write the code. Okay, so this is our tree. I'll take the same tree again. Okay, so wherever first thing, whenever a traversal starts, it always starts from the root. Okay, so what pre-order means? Pre means first we will visit root. After visiting root, we will move to the left side, that is left of the root. Okay, then after visiting the left, we will move to right side, that is right of the root. So this is the main idea or the center idea of this type of this pre-order traversal. Let us do a dry run. Okay, so I am here at root. Let us name it. Okay, 1 2 3 4 5 6 7 8 9. Okay, so these are just numbers. Don't confuse with the binary search tree, which I told that the left should have the lesser value than root and right should have the larger value. I'm just telling you an example. Okay, so let us start. Here I am at root 1. Okay, so first I'll visit 1. I'll print it. Now I'll move to the left side. After visiting this one node, we'll come to the left side where we see 2. Okay, so we will visit this 2 again. We will visit this 2, comma, I print this 2. Okay, now does it have a left node? Yes, it has. What is it? It is 3. So now we came from 1 to 2, then from 1 to 3. Okay, the center idea remains the same, that is root then left side. Till we have the left side, we will not move to the right side. Okay, this is a recursion. From 1 to 2, then 2 to 3. Okay, 3. Now we'll visit 3 again. From 3, it will ask, does it have a left side or a left node? It say yes. So now we'll move to 4. Okay, we'll visit 4. Now does 4 have a left node? No, it does not. Okay, no problem. What to do now? Return back to this node. Okay, now it came to 3. Now 3 has executed this, 3 has executed this, but 3 has not executed this. So now it will come to 6, come to like what number it is? It's 5, sorry, it's 5. So now it will visit 5. I'll print 5 again here. Now 5, does it have a left, right? No, it does not. It will return back to 3, and 3 have completed this, all these 3. Now it will come back to 2. Okay, 5 has completed. Okay, now it comes to 3. 3 has completed these all 3. It will come back to 2. This is a recursion call. Okay, come back to 2. 2 has executed this, but not this. So it will print this its right side, 6. Does 6 has any left or right? No. Okay, then it will return back to 2. Now from 2 it will come back to 1. Talking about 1 has executed this part and this part. Now it will move to right. Okay, it will move to right. 7, here we get 7. Okay, from this 7, does it have a left? Yet it does have a 7, does have a left node. So it will come to 8. It will print 8. Okay, does 8 has left or right? No, it does not. Then it will return back to 7. From 7 has executed this, but not this. 7 will come down to 9, and I will print 9. Does 9 have a left or a right? No, it does not. Then it will come back to 7. 7 has executed all these 3. Then it will return back to 1, and 1 has executed all these 3. So here the recursion call ends, and this is our output. Okay, so I think you must have got a pretty much idea of how I did a dry run of how this is this pre-order traversal. Now I will write the code just like the same, just like a story which I told you just now. Okay, so okay, this is a code. Okay, void pre-order. Okay, here I'll give the parameter as root. Okay, parameter here is root. Okay, the base case is if what if the root is itself null, then what to do? If it is null, then no, then it would not even have the root or the node value. Then simply return, do nothing, simply return. Okay, now what we have to do? First we have to print the root. Okay, so I will print the root, system.out.println. I'm using Java as my coding language, but you can take the logic, you can get to know about the concepts, and the language doesn't matter. What matter is the concept and how you approach the problems. Okay, system.out.println, not println, I'll print root.val plus some empty space. Okay, now I've executed this part. Now I will move to left part. Okay, then I will call this preorder root.val, sorry, root.left. Then after executing this call, it will move down to right side. That is, I will call to this function preorder, but now with root.right. So this entire code will execute this pre-order traversal, and by looking just these 3 lines which I told you earlier, pre-order. Okay, pre-order is a hint, the name itself is a hint. Pre-order, that is, we first visited the root, that is pre, then left, then right. Okay, so I hope you get it well, the pre-order traversal. So now we'll move on to Inorder Traversal. I again took the same example of the tree. Okay, before starting this, it is a kind of a characteristic or a property, you can say, that in a binary search tree, in a BST, that is a binary search tree. You know what is a BST? BST is a binary tree where the left nodes have the lesser value and the right nodes have the greater value of a particular node. In a BST, if we do a in-order traversal, in-order traversal gives a sorted order. In-order gives a sorted order. It can be asked in any of the interview or maybe university exams in a MCQ that which order gives a sorted, which traversal order gives a sorted sequence in a binary search tree. Okay, so you can write in-order traversal. Okay, so now we'll proceed. Just like I told in the pre-order, this sequence I'll tell in the in-order what we will do. First we will visit the left side of a node. Okay, after left side, what we'll do, we'll visit the root, that is node. Then after that node, I visit the right side. I'll visit the right side, that is the right nodes. Okay, now first do the dry run and understand how this recursion works here. So here in this we always start from the root node. Okay, so our root node is 1. From this, as we know, we'll go left, then root, then right. Okay, from this I'll go left 2. Okay, I'm here at 2. Does 2 has left? Yes, it has 3. So it will come down to from 1 I came to 2, then from 2 I came to 3. Does 3 has the left? Yes, it does. I'll come to 4. Okay, does 4 has left? No, 4 does not has left. That means 4 has executed this. Okay, now root, I'm at root, I'll print the root. Okay, I'll print 4 here. Okay, from 4, so 4 has executed this, 4 has executed this. Now 4 does 4 has right? No, it does not. That means 4 has executed this, and now recursion call comes from 4 to 3. Comes to 3. 3 has executed this. Okay, 3 has executed this. Now I'll print 3. Printing 3 will execute this for 3. Okay, now does 3 has a right? Yes, 3 has a right. So now this will come from, the recursion call will come from 3 to 5. Okay, from 5. Does 5 has a left? No, it does not. That means for 5 this is executed. Okay, 5 comes this. 5 will print 5 here. Okay, that means for 5 this is executed. Does 5 has a right? No, it does not. That means for 5 this is executed. Yes. Now recursion call from will return from 5 to 3. Now for 3, this all 3 is executed. Now the recursion call will come from 3 to 2. Okay, for 2 this has been executed. Now this has to be executed. We'll print 2. Now it will print 2 has executed this. Now a recursion call will come from 2 to 6 because 2 has a right side. Recursion call will come from 2 to 6. Okay, does 2 has a left? No, it does not. That means this call is executed. Will print 6. Okay, printing 6 here will execute this for 6. Sorry, does 6 has a right? No, it does not. That means this is executed for 6. Recursion call will come from 6 to 2. Okay, 2 has executed this. Okay, now recursion call will come from 2 to 1. Okay, 2 has executed its left side. Now by printing 1 it will execute this for 1. Recursion call because 1 has a right side, so a recursion call will come from 1 to 7. Okay, coming to 7, it will ask that does 7 has a left side? Yes, it does. So this will be executed for 7, and recursion call will come from 7 to 8. For 8 it will ask does it has a left side? No. So this will be executed. Now it comes here, it will print 8. Okay, by printing 8 it will execute this. Does 8 has a right side? No, it does not. So 8 will execute this also. Now recursion will come from 8 to 7. For 7 this has been executed. Now for this we'll print 7. Does 7 has a right side? Yes, it does. So the recursion call will come from 7 to 9. It will ask, does 9 has a left side? No, it does not have. So it will execute. It will be executed for 9. By printing 9, it will execute this. Will print 9. Okay. Does 9 has a right side? No, it does not. So it will execute this as well. Now we'll move on. The recursion call will move from 9 to 7. 7 has executed this. So recursion call will return from 7 to 1. Okay. For 1, this and all these three are executed. That means the traversal is done. So this was the dry run of how this Inorder Traversal works. Now I'll write the code as well for that. Just like I told you this like a story, I'll write the code as well. It is very easy. Okay, it is just similar like this one. Just we'll swap 1 or 2 lines and it will become Inorder Traversal. Okay, I'll write the code. Void Inorder. Here I'll pass parameter as the root node. Again, the base case is, what if the root is null? Like if the root is null, do nothing, just return. Okay. What we were doing, we were first visiting the left sides. So I'll call this Inorder to root.left. And when all the left sides are completed of a root, it will print root. So I'll do system.out system.out.print what root.val with some empty space. After completing this, it will move to right side. So I'll call Inorder and the parameter I'll give is root.right. So that's it. This is our code for Inorder Traversal. You can see it is just like this one. I've just swapped this line with this line. Okay, so this was Inorder Traversal. Okay, now we have the third type of traversal in binary tree, that is Postorder Traversal. I have this example. Okay, so now first I'll tell you how we'll go in this tree. Just like it says Postorder, that means we'll visit the root node at last. How we'll go? First we'll visit the left side. Okay, after visiting left side, we'll visit the right side of a root of a node, and after left then right, then after left we'll do right, then after right we'll visit the root. Okay, so that's how it'll be from left to right. Let me write it in a single line. We'll move from left to right and then from right to root. This will follow. Okay, now first what we do a dry run. Okay, so I'm here. Okay, let me draw it again once again, a clear picture of the diagram. 3, 4, 5, 6, 8 and 9. Yeah, so I'm here at 1. So for 1, it will ask, does it have a left side? It say yes. So for 1, this will be executed and the recursion call will come from 1 to 2. Okay, from 2 it will ask, does it has a left side? It say yes. So recursion call will come from 2 to 3. For 2, this will be executed. For 3, it will again ask, does it has a left side? It say yes. So recursion call will come from 3 to 5. Okay, so for 5, it will ask, does it has a left side? It say no. So this will be executed for 5. Now for right, does it has a right? So no, it does not has a left, not even a right. So this will also be executed for 5. Now root. So now we'll print 5. Okay, so for 5, all these are executed. So recursion call will come back from 5 to 3. For 3, this was executed. It will ask, does it has a right side? It's a yes. So for 3, right call will be executed. So recursion call will come from 3 to 6. 3 to 6. For 6 it will ask does it has a left right? It's a no. So both these will be executed. Now for this we will print 6. For 6 all these calls are executed. So recursion call will come from 6 to 3. By coming 3 we will be for 3 these 2 calls are executed. It will execute this call by printing 3. For 3 all these calls are executed. So there will be a recursion call back to 2. Okay, for 2 these 2 are for 2 this was executed. Now it will come right of 2, that is 4. For 4 there is no left and right, so these will be executed. For this to be executed we will print 4. For 4 these 3 are executed, so it will do a recursion call back to 2. For 2 these 2 are executed. For this to be executed it will print this value 2. Okay, for 2 all these are executed, so there will be a recursion call back. After coming to 1, for 1 the left side is executed. For right side recursion call to 7. For 7 it will go to the left of 7. Okay, for 8 there is no left and right, so these 2 are executed. For 8, for this to be executed we'll print 8. Okay, after printing 8 all these 3 are executed. Now there will be a recursion call back to 7 again. For 7 we had visited its left side, now we'll visit the right side, that is it will come to 9. 9 there is no left and right, for this to be executed we'll print 9. Okay, we'll print 9. After printing 9 all these are executed for 9, so there will be a recursion call back to 7. For 7 to be executed these 2 are executed. For this to be executed we'll print 7, and all these 3 are executed for 7. After completing this, a recursion call back to 1. 1 has completed left and right. Last thing, that is this, will print 1, and for 1 all these 3 are executed. So that's our recursion call done. So similarly I'll write the code as well. So here I wrote the code for Postorder Traversal. You can see it is just like same as pre-order and post-order, just swap of these 3 lines. As I told, in post-order first we'll visit left, so I did a post-order recursion call to root.left. Then right, I did call to root.right, and after that visiting root, that is printing root, I printed root at last, that is root.val with some space. So this is what are these 3 types of traversal: pre-order, in-order and post-order traversal. I did a very detailed dry run, and after that I wrote code of all these 3. You can solve it by yourself as well, and write code in any of the languages, C++, Java, Python, anything. Just your concept should be strong, and if any doubt, drop it in the comment box. Thank you for watching.